I'm Frank Hermes, and this is Rocket Electronics. And this is the series of videos that will hopefully orient you to the features and use of the new RockeTiltometer. The RockeTiltometer is basically a two-board device. There's actually a third board that you can't quite see, but is up inside there, and that is where the gyros are actually housed, and the gyros are the heart of the RockeTiltometer. Also on the lower board are 3 slide switches where you can set the critical angle from an angle of 5 degrees off the vertical axis all the way up to 40 degrees in 5-degree increments. And there's a table in the user manual that describes how to make those settings. There's a couple of LEDs here that are for system statusing. There is a logger board that sits below the upper board and contains a micro SD card for recording data during flight. The top of the board, this is the orientation that it normally sits in, is the vertical orientation, and there is an arrow here that you can see that tells you which is the pointy end up. Lower terminal strip is T3. There are 3 main terminal strips, T1, T2, T3. T3 is the what we'll call the system terminal strip, where you would place attach the system battery, a system on-off switch, and there is also a set of terminals here for a remote indicator in case the RockeTiltometer is buried inside the airframe and you won't be able to hear the beeper that's in there to give you diagnostic and status tones. You can run an external device out to the outside of your airframe, either an LED, another beeper, whatever it might be, and it basically just parrots the audible tones that are coming off of the system beeper. T2 is the terminal where there is a source for the ignition. The ignition source for your air start motors or stage motor or motors comes from the RockeTiltometer. There's a high capacity FET ignition circuit here. So when an external device calls for ignition, we call that the trigger signal. When the RockeTiltometer gets that, if the RockeTiltometer is within the critical angle off the Z-axis that you specified, the ignition will go ahead and activate off of the RockeTiltometer board. And if not, if it has exceeded the angle off of Z, then it will abort or inhibit ignition. So this terminal strip allows you to attach a separate source. This is high capacity again, so it's separate from the system source that's running the RockeTiltometer. And it is rated 12 volts up to 25 amps, so it's a high capacity circuit in case you have several igniters on. But it uses a separate source to keep that isolated from the source that's running the RockeTiltometer. There's an on-off switch set of terminals here, set of terminals for your igniter or igniters, or another outboard circuit again that needs to be activated at trigger time. And then there are terminals for external trigger inputs, either just what we call active low, which would be if you just have a switch transistor, as many altimeters and timers do, or there is a set of what we call active high, which takes actually a switch voltage into it. So examples of those on the active low is if you had a Raven altimeter, for example, and using one of the pyro channels to activate or to call for ignition, it actually just switches a transistor and takes it to ground, which would then what we call low, and that would be the trigger signal calling. Or if you had a Xavian timer, for example, they actually switch a positive switch voltage, and that could be used as a trigger signal for the RockeTiltometer. So between those two inputs, pretty versatile, should be able to handle almost any trigger signal that you would apply to the RockeTiltometer. The top set of terminals are actually an extension of this header. This header is designed to allow you to nest a Raven flight computer on the RockeTiltometer in this fashion. You can see that it sits right in there, bolts right up. In this configuration, we would use the Raven's 4th pyro channel to actually call for ignition. So you can refer to the Featherweight Altimeter's website, the manual for the Raven, and you can see that each of the 4 pyro channels that are on the Raven altimeter very versatile, and you can set them for virtually anything, for normal dual deployment channels down to a simple timer and lots of things in between. And in this case, what we use is the 4th channel, so you would program the Raven in a configuration that you wanted to act as the trigger signal. And so that 4th pyro channel, when that comes up and goes true and calls for ignition, we use that as an active low signal into the RockeTiltometer. And again, if the critical angle has not been exceeded and it receives that triggering signal from the Raven, then we would activate the ignition circuit. If it had exceeded it, it would inhibit ignition. Well, so since the Raven is nested here, we didn't want to waste the other features of the Raven. So on this terminal strip, the other 3 pyro channels, channel 1, 2, and 3, are brought out on 2-wire circuit, so you can wire directly 2 wires to it for E-matches, igniters, etc. If you have a load, while the Raven is nested in the RockeTiltometer, it's using the system voltage source. So if you're just using E-matches, for example, or you're going to set this up and then use a couple of the other channels in the Raven for dual deployment, for example, and you're just popping an E-match, then this system source would be plenty. But if you get in something bigger, or you are just concerned about the load on the system, you can actually attach a separate Raven pyro supply to this terminal strip. There's an on-off switch for it, so you don't run your battery down while it does its continuity checking. And you just switch over this little jumper from system source over to external source for the Raven. So that's kind of just a brief overview of the new RockeTiltometer, and we'll have a series on connections for each of the terminal strips and how to use it, apply some power, etc.